Welcome! This video introduces step response for series RC high-pass filter circuits driven by a voltage source.
Step response is the circuit response behavior to a sudden application of an input signal. In this case, the input voltage is stepped from 0 to V sub s instantaneously.
The step response to a first-order circuit is an exponentially growing or decaying signal. To denote a step function input, highlighted in yellow, we can use the small step symbol next to the voltage source schematic symbol. To model or illustrate a step function input, we can use an ideal switch in the circuit. The switch changes position at time 0. Here, the switch is shown in between the two positions. When the switch is in the lower position, there is no voltage or current in the capacitor and resistor. When the switch is in the upper position, the voltage source DC value, V sub s, is connected to the RC network. When the switch changes positions instantaneously at time 0, the circuit goes from 0 voltage and current to having the voltage source V sub s instantaneously applied to the RC circuit. We can sketch the RC high-pass step response behavior intuitively, remembering that you can't place an instantaneous voltage across a capacitor. When the voltage source V sub s instantaneously drives the RC circuit, all the V sub s voltage initially falls across the resistor and no voltage initially drops across the capacitor.
For more technical background and insight on capacitor voltage and RC step response, please see this book, available from John Wiley Sons.
The voltage across the resistor creates a current which fills the capacitor with charge, increasing the voltage across the capacitor and decreasing the output voltage Vout across the resistor. This decrease in Vout voltage decreases the current in the resistor. The capacitor voltage quantity, V of Vin minus V of Vout, increases asymptotically up to the voltage source value V sub s, which is 1 volt in this simulation. The resistor voltage Vout decreases asymptotically to 0. Here we can see a different view of the same RC high-pass circuit topology, starting with the voltage source V of Vin being stepped from 0 to 1 volt. The resistor voltage also instantly steps up to the source voltage value of 1 volt. Then the output exponentially decreases while the capacitor voltage increases. By comparison, the voltage responses in the previous RC high-pass filter topology are swapped here in the RC low-pass circuit on this slide and featured in the video RC step response description. Here in RC low-pass step response, the output voltage across the capacitor rises exponentially from 0 to the source voltage of 1 volt. Notice how in both cases, the capacitor voltage rises and the resistor voltage decays. The output voltage taken across the resistor is a decaying exponential, V sub s times e to the minus t over tau. For this RC circuit, the time constant tau equals RC the resistance times the capacitance, which is equal to 400 nanoseconds or 0.4 microseconds. More generally, a decaying exponential function is e to the minus x. Here, the exponent x is the quotient of time t divided by the time constant tau, which is 0.4 microseconds for 20 ohms resistance and 20 nanofarads capacitance. Note the horizontal axis markings for tau, 2 tau and 3 tau.
Thank you for watching and learning with us.